Welcome back, children. Now we can do problems based on independent events. So first one fair coin and an unbiased die are tossed. Let A be the event, head appears on the coin, and B be the event, 3 on the die. Check whether A and B are independent or not. So what is the experiment? A fair coin and an unbiased die are tossed. So what about the sample space? Coin and a die. For coin we have two possible outcomes, head or tail, and for die 1 to 6 numbers. So sample space means the coin with the die. So H1, okay, one is H1, then H2, H3, H4, H5, H6. Then with the tail T1, T2, T3 up to T6. So there are 12 outcomes. Now what is A? A be the event, head appears on the coin. So what is probability of A? A be the event, head appears on the coin. So only these 6 are there. So 6 out of 12. It is 1 by 2. P of B, B be the event, 3 on the die. 3 on the die. So on the die 3, T3 there, then H3 also. H3 and T3. So 2 out of 12. That is 1 by 6. Then what we have to find? We have to check whether A and B are independent or not. So for independent we have to check P of A intersection B, whether it is equal to P of A into P of B. So first we can find what is A intersection B. What is A intersection B? A means head on the coin. B means 3 on the die. Is there intersection? Yes, we have one element, that is H3. So P of A intersection B is equal to 1 out of 12. Now find what is P of A into P of B. P of A into P of B is equal to 1 by 2 into 1 by 6. That is 1 by 12. Therefore, P of A intersection B is equal to P of A into P of B. Hence, A and B are independent events. Independent events. Okay, so for checking independent, you have to find P of A intersection B, whether it is equal to P of A into P of B. If it is not equal, then they are not independent events. Second one, given that the events A and B are such that P of A is 1 by 2, P of A union B is 3 by 5, and P of B is P, small p, find that P, if they are, two cases are here, mutually exclusive and independent. So P of A given half, P of B means it is small p. Then P of A union B is given. P of A union B is equal to 3 by 5. What is P of A union B? P of A plus P of B minus P of A intersection B. This is equal to 3 by 5. Now take the first question. If they are mutually exclusive, that is A and B are mutually exclusive. If A and B are mutually exclusive, what is the condition? A and B are mutually exclusive means intersection. Mutually exclusive means intersection is equal to null set. Then A intersection B is equal to null set. So probability of A intersection B is equal to 0. Probability is 0. So P of A. What is P of A? 1 by 2 plus P minus 0 is equal to 3 by 5. which implies what is P? 3 by 5 minus 1 by 2. So it is 1 by 10. Now the second is independent. A and B are independent. If A and B are independent, then we can write as P of A intersection B is equal to P of A into P of B. Okay, so this becomes half plus P minus P of A into P of B is equal to 3 by 5. Again substitute for P of A and P of B. So half plus P minus half into P is equal to 3 by 5. P minus P by 2. That is 1 by 2. 1 by 2 P is equal to 3 by 5 minus 1 by 2. So which implies P, half P is equal to, it is 1 by 10, which implies P is equal to, we can cancel this. So P is equal to 1 by 5. So in the first case P is equal to 1 by 10 if A and B are mutually exclusive. Second case, A and B are independent, then P value is equal to 1 by 5. Third one, given two independent events A and B such that P of A is equal to 0.3, P of B is 0.6, then find, four subdivisions are here, P of A and B, P of A and not B, P of A or B, P of neither A nor B. P of A and B. A and B same as P of A intersection B. Isn't it? A and B, and the notation is intersection or is union. Then since A and B are independent, we can write this as P of A into P of B. Okay. P of A intersection B is not always P of A into P of B. If A and B are independent, then only you can write like this. P of A is given as 0.3 into 0.6. So it is 0.18. Now the second one, P of A and, so intersection, not B. Not B means B complement. That's the meaning. A intersection B complement. Now how we find A intersection B complement? A and, given that A and B are independent, A and B are independent. So A and B dash also independent. If A and B are independent, A and B dash are independent, A dash and B are independent, A dash and B dash are independent. So A and B dash are independent. So if A and B dash are independent, we can write as P of A into P of B dash. P of A is 0.3 into P of B dash is 1 minus P of B. P of B is 0.6. So 0.3 into 0.4, that is 0.12. Okay. Now the third one, P of A or B. A or B notation is A or B union A union B. P of A union B is P of A plus P of B minus P of A intersection B. And intersection already here its value is there. Just substitute 0.3 plus 0.6 minus 0.18. That is 0.9 minus 0.18. 0.90, 0.18. So it is 72. Okay, so 0.72. 0.72. Now the last one, neither A nor B. Neither A means it is A complement, nor B, A complement intersection B complement. Here also we can use this result. A and B are independent, A and B dash are independent, A dash and B dash are also independent. Otherwise you can use De Morgan's law, that is A complement intersection B complement is A union B whole complement, then 1 minus P of A union B. In that way also you can calculate. Okay, that is one method. The other method is using independence. Anyway, we are studying that, so we can use the result of independence. So P of A complement into P of B complement. A complement, what is P of A? 0.3. So 1 minus 0.3 into 1 minus 0.6. 0.7 into 0.4. That is 0.28. Okay. Next one. A die is tossed thrice. Find the probability of getting an odd number at least once. So a die is tossed thrice means sample space. In sample space there are 216 elements. Okay. 1, 1, 1, 1, 1, 2 like that, 1, 1, 6. Then 1, 2, 1, 1, 2, 3 like that. So there are, the last element is 6, 6, 6. There are 216 outcomes. Then the question is, find the probability of getting an odd number at least once. So it's a triplet. Odd number at least once means one or more. At least once means one or more. That's the meaning. So one odd number or two odd numbers or three odd numbers. So all these you have to consider and find the probability. Okay. So but that is little bit difficult, isn't it? It's very difficult to check first odd number, how many outcomes are there, then first and second, how many, or first and two odd numbers, any places. One place odd number, two places odd number, then three places odd number. Counting is very difficult. So we do in just opposite way. We can take the complement, that is we use this result P of A and 1 minus P of A complement. Both are same. P of A and 1 minus P of A complement. P of A complement means 1 minus P of A. 1 and 1 cancel, P of A we get in the right hand side also. So using this result, P of, we have to find probability of getting an odd number. An odd number at least once. At least once. That's equal to 1 minus. 1 minus. What is the complement of this statement? At least once means one or more time odd number. So its opposite is, we have three places. It's a triplet. So its opposite means in all the three places getting an even number. So that's the complement. So probability of getting an even number in all the three tasks. That is in that triplet all the numbers, even numbers. Okay. Now how we calculate that? The experiment is a die is tossed thrice. A die is tossed means 1, 2, 6 in that die. So getting an even number. What is the probability of getting an even number? This also we can do in different ways. The one method is like this. Probability of getting an even number. When we throw a die. Die, there are 6 digits, 6 numbers, 1 to 6. So getting an even number means either 2, 4 or 6. That is 3 out of 6. That is the probability of getting an even number. Odd number also same. So it is 1 by 2. Getting an even number is 1 by 2. So we can write this is the required probability. So required probability is equal to 1 minus getting an even number in all the 3 tosses. That is probability of the first place is even, the second place is even, the third place is even. So you can write like this. 1 by 2 means probability of getting an even number in the first place. Again 1 by 2, probability of getting an even number in the second place, into 1 by 2, probability of getting an even number in the third place. So 1 minus 1 by 8, that's equal to 7 by 8. This is one method. Or required probability is equal to 1 minus getting an even number in all the 3 tosses. So in all the places even numbers we have to get. Like that, how many numbers in that 216 outcomes? So first place even, second place even, third place even. Okay. So first place even, how many cases? We have 1, 2, 3 up to 6 numbers. So in that even numbers are 3, 2, 4, 6. So this place we can fill in by how many ways? We are using permutation. Okay. So this first place even, second place even, third place even. So first place we can fill in by 3 different ways, isn't it? And the third one, second one also 3 different ways, third one also 3 different ways. All 3 are even numbers. So total means you have to multiply by multiplication principle. So it is 3 into 3 into 3, that is 27. So we can write the probability as 27 by 260. Okay, when we write probability, this favorable by, so only 27 numbers, in 27 numbers only all the 3 digits are even. All the 3, not digit, all the 3 places are even. So 27 out of, when we write probability you have to write by total, it is 216. Now we can simplify that. So 216 minus 27 by 216. What is 216 minus 27? 3. 189. 189 by 216 we can cancel by 9. 21. 9 to 24, that's equal to 7 by 8. Is this answer same? Okay. So either this way or this way. Understood this? So the question is tossing a die 3 times. That's the question. What is the probability of getting an odd number at least once? At least once means 1 or more. So when we throw a die 3 times, we get a triplets. There are 216 outcomes. So the counting odd number at least once is difficult. That's why we take the just opposite like this, using this result. P of A is same as 1 minus P of A complement. So required probability is 1 minus P of the complement of this statement. So getting an even number in all the 3 tosses. Then getting an even number means the probability 1 by 2. So 3 times you have to multiply 1 by 2. That is the answer. One method. The other method, how many even numbers are there? In all the places, even numbers, how many are there out of 216? For that we can use this permutation, 3 places and 3 places even. How many even numbers? 1 to 6, there are 3 even numbers. So 3 ways, 3 ways, 3 ways, that is 27 ways. So this is the required probability. then subtract and simplify. Now the last one. Probability of solving specific problem independently by A and B are 1/2 and 1/3 respectively. If both try to solve the problem independently, find the probability that the problem solved, exactly one of them solves the problem. So A and B. Probability of solving specific problem independently by A and B are 1/2 and 1/3. So just I denote P of A. A means probability that the problem is solving by A independently is 1/2. P of B means the problem is probability that B solves the problem independently is 1/3. Okay. Then the question is, find the probability that the problem is solved. So problem is solved means either A solves or B solves. So the notation for the problem solved we can denote as A union B. A union B. So what is P of A union B? P of A, P of B minus P of A intersection B. And A and B are independent. Here it is independent events. So here we can write as P of A plus P of B minus P of A into P of B. They solve problem independently. One of them does not depending on the other. So we consider as independent events. Now substitute the values. 1/3 minus 1/2 into 1/3. So 1/2 minus 1/6. So here 5/6, that is 4/6 equal to 2/3. Okay, the problem is solved, either A solves or B solves. Now the second one is exactly one of them solves the problem. Exactly one means if A solves, B cannot, or B solves, A cannot. Like that you have to take. So probability of, what is the notation? If A solves the problem, then you have to take the case of B not. Okay, simply you can write P of A, that is wrong. So A solves the problem, B cannot means B dash, B complement, and in between you can put intersection. Both we need now. Both we need, so you can put intersection symbol. Okay. So either this case or what is the case? Either means you have to put plus symbol, plus, or union symbol. Okay, here I put union symbol. Okay, union. What is the next case? A not solving the problem but B. Is the notation correct? Once again you check. Exactly one of them solves the problem. So if A solves, B not solving that problem. So both we need. So you have to put intersection symbol. Either this case or that case. So either or means union. Okay. Like this you have to do. What is P of? Into this. So this portion is A intersection B. This is A intersection B complement. Here is A complement intersection B. And these two are disjoint now, no intersection. So when we expand, this is of the form P of A union B. P of A union B is P of A plus P of B minus P of A intersection B. Intersection of these two set is 0. Minus P of A intersection B complement intersection A complement intersection B. So that last part is 0. Since A and B are independent, A and B dash are independent. So we can write A into B complement plus A dash and B are independent. And the last part is 0. Now you substitute P of A is 1 by 2. P of B is 1 by 3. So B complement means 1 minus 1 by 3 plus 1 minus 1 by 2 into 1 by 3. So 1 by 2 into 2 by 3 plus 1 by 2 into 1 by 3. So 2 by 6 plus 1 by 6. That is 3 by 6, that's equal to 1 by 2. Is it clear? It's equal to 1 by 2. Okay.